So, good afternoon. My name is Monica Moskal. I'm a professor of remote sensing here in the School of Environmental and Forest Sciences, and I'd like to welcome you to our weekly SEFS seminars in person and on Zoom, and now you can hear me. Today, I have the pleasure of introducing you to one of my colleagues, Dr. Susan Prichard. Susan is a fire ecologist and has worked with SEFS for the last 18 years. Her main interests are the effects of fire and other disturbances on forest dynamics and climate change, as well as fuel treatment options to mitigate fire severity and smoke impacts in dry forests. She lives full-time in the Matau Valley near Winthrop, Washington. Having lived through record-setting wildfires this past season, she is focused on applied research questions that help to inform adaptive management under climate change. And I'll let Susan take over.
Right. We covered this one other time, but I just wanted to have anyone raise their hand if they're not comfortable with me taking my mask off. I'm happy to keep it on, but otherwise I'll take it off for this presentation. Okay, great. All right, today I've been pretty excited to share with you a presentation on common questions about adaptive forest management. Let's see, I'm having trouble. There we go. Before I begin, I wanted to respectfully give a land acknowledgement. As part of the University of Washington, I respectfully acknowledge the Coast Salish peoples of this land, the land which touches the shared waters of all tribes and bands within the Duwamish, Puyallup, Squamish, Tulalip, and Muckleshoot nations. I also am bringing in quite a bit of perspective from where I live in Eastern Washington in the Matau Valley. So I respectfully acknowledge the Matau people who have lived and cared for the Matau Valley for thousands of years, including their cultural burning practices. I recognize that we can and must do more to build better relationships, support their voices, and acknowledge our past. All right. We have a recent article that was published rather unorthodoxly in Ecological Applications. It's not a standard publication for them. And our goal for this publication was really to guide science-based strategies for restoration and adaptive management of fire-prone forests. So we will get to some of these questions, but I'm also including a lot of hyperlinks in this presentation. Happy to share the PowerPoint or PDF with you afterwards so that you can read some of these sources. Hopefully I'll inspire you to do so. This was a big project. We wanted to ask colleagues from around the Western United States, Canada, and into Mexico to collaborate with us. And so we had over 40 co-authors in this invited feature. And then our funding partners were really gratifyingly diverse. So we have some state and federal partners with this, but we also have the Wilderness Society, Conservation Northwest, the Nature Conservancy. So really fortunate to have the funders that we did for this project. So when I actually was inspired to lead this effort, it was doing one of my favorite things, which is run in the forest. And I have a lot of good ideas about it, but I also ruminate on things that frustrate me. And so one of the things that frustrates me is that evidence of fire exclusion is so apparent, through the kilometers and kilometers of trails that I've run in my area. I've found a lot of forests that just have too many neighbors, and too much fuel on the ground. So on the left is a picture near Sun Mountain Lodge in the Matau Valley. And this forest on the left was spared by the 2021 fires this summer. But the right photo is all too common these days of large fire-resistant, what should be fire-resistant ponderosa pine, 300-400 years old, that die in these fires because of too many neighbors and too much fuel on the ground. Well, as we talk with our colleagues as fire ecologists, this is a common refrain. I had the privilege of actually visiting the ancestral homelands of the Karuk people with Bill Tripp and Dr. Frank Lake this past summer. And in the Western Klamath, tan oak has been invaded. Black oak has been invaded too, with a lot of conifers. And so cultural burning practices are being revitalized to bring these forests back. And so this has been a journey for me. I used to have a really strong bias against Smokey the Bear and blamed it all on Smokey. Over time, especially with reading articles by Jim Agee and Paul Hesberg and others, I realized that my lens about why we are in the situation that we're in today was too narrow. And so this puts it a little bit too mildly, but colonialism, curtailment of indigenous burning is a big factor. Fire suppression has definitely played into this. But I actually didn't realize this for a while, but livestock raising had a role. Road and rail construction, high-grade logging, all these factors kind of came together to mean much less fire on our landscapes. And now, of course, we have climate change, which is heating up these forests and making them often drier and more susceptible to fire. So here's a fire scar record. We actually can see a really sharp drop in the number of fires after 1883. We need to recognize that fire regimes had already shifted through colonialist ways and a lot of disease. So already in the 1700s, 1800s, there was less fire, but then there's this conspicuous loss of fire after 1880. Tom Swetnam put together 800 sites throughout the Western United States and showed something really similar, basically high fire frequency before 1900, right around 1880. And then widespread sheep grazing and cattle grazing hit. And that actually was kind of a big stopper for those frequent grass fires that would burn under pine or oak savannas. And so a lot of that high frequency fire was lost actually through widespread grazing and then fire suppression. You probably have seen this, but I love these diagrams by Baum Van Pelt, so I put one in. The top photo or image shows a fire-maintained forest that would have had patchy, low to moderate severity fires that punched hole in the forest but kept the large, say, ponderosa pine in this image. And now we have this fire exclusion with a lot of infilling. That also has happened across our landscapes. And so we often, I think oftentimes in terms of a patch, but across landscapes, Paul Hesberg and many others have used photo interpretation to show that over the 1930s or 40s to the present day, we've also had infilling. So we've lost a lot of our grasslands and shrublands to infilling of trees. So not only a densification of forests where they exist, but also an expansion of forests. So that's predisposed our landscapes to more large, high severity fires. Certainly the Western wildfires we're having have mixed severity effects. Some of them have low severity or moderate severity effects, but we're having more patches of what we call stand replacement fire, which is shown here near where I live in the 2014 Carlton complex. When I actually did my master's here at the college, our school, and Linda Brubaker inspired me to actually go into fire with this problem right here, which is that she kind of taught us how mature trees have a lot of inertia. They're built to last. Certainly we're seeing some trees die from record-setting heat waves, but overall a mature tree has a lot of reserves and a lot of capacity to handle the bumps within climatic variability. Not so for tree seedlings. They have very shallow root systems, low carbohydrate reserves. And so whatever season that they're trying to reestablish is critical for them. Fortunately, trees often have a lot of seeds, so there's a lot of seedlings to try to make it out there. But with this confluence of a lot of high severity fire acting at the same time that summers are becoming longer, warmer, and drier, this is kind of a sobering reality for forests to try to reestablish. So I've been really excited about doing a lot of my research on this topic of dry forest restoration or adapting these fire-prone forests to climate change. One of the best strategies that is really inspiring is the National Cohesive Wildland Fire Management Strategy. Quite the mouthful, so I often only say cohesive strategy. But this is a really great plan to go across ownerships, say Washington DNR, Forest Service, tribal lands, private lands, and have a three-pronged or three kind of legs to a table approach to restoration. So this would include restoring and maintaining fire-adapted landscapes, building and maintaining fire-adapted communities, and assisting with safe and effective fire response. Great idea. However, it's become so frustrating for those of us that are passionate about this to see how little work is actually getting done on the ground. So that actually inspired this topic. Crystal Colden wrote a paper. She's often as a one of journalists called her spicy. I love her work. She wrote a paper on we're not doing enough prescribed fire in the Western United States to mitigate wildfire risk. And these are two graphs from her paper. One shows prescribed fire acreage accomplished. It doesn't look so bad. You see this upward trend, actually all in the southeastern United States. Other regions, including Western United States, flat. Even as wildfires, there's an upward trend in not only fire area burned, but also severity. Okay, a lot of factors are coming into why we're not getting a lot of work done. Some of this is funding, competing funding for fighting fires versus actually treating fuels on the ground. But another thing that's come up for those of us in this arena is that there's conflicting messaging. So you're going to get an excellent presentation next week by Malcolm North. And he wrote a very insightful article, Reform Forest Fire Management. Bill Tripp and other Indigenous leaders are really speaking up about revitalizing cultural burning practices. And some, certainly not all, people who are worried about expanding, say, forest thinning and fire are also speaking up. So there's a lot of information out there, both in the scientific literature and in the media. So one of the issues around this is that when managers propose active management on public lands, they need to prove that it's going to do more good than harm. And unfortunately, reacting to uncertainty can sometimes catalyze this precautionary principle, paralysis by analysis. We need more information. We need to reduce the uncertainty before we can begin. And so as a group of fire ecologists, we're pretty passionate about getting work done. We decided to come together and acknowledge that we know a lot. We actually have a lot of science-based evidence of what works, and we wanted to put that together in a pretty easy to use paper for managers and other scientists. So Paul Hesberg wrote this quote. I'm not going to have time to read all the quotes in here about our impetus for this invited feature. So today, Paul actually recommended that I give you 3 or 4 of these, but I couldn't help myself. Some of them are so closely connected that we're going to do 6 today, but I'm going to address some of these common questions and just kind of unpack them for you and hopefully inspire you to read the rest of the article. Okay, the first question that we asked is about our forests, our Western forests actually departed. And I've already kind of proven the case that I think they are, and a lot of scientists do. But there's actually been a narrative in the scientific literature that says the opposite. And I'm going to read this quote. This is by Bill Baker and L. I forget L's first name. Our analysis suggests that repeated prescribed burning of large areas of ponderosa pine forest at short intervals lacks the sound basis in science. It should not be done at the present time if the goal is restoration. In most parts of the Western United States, there is also insufficient evidence to support the idea that mixed or high severity fires were or were not absent or rare in the pre-Euro-American fire regime. Thus, programs to lower the risk of mixed or high severity fires in ponderosa pine forests have insufficient scientific basis if the goal is restoration. Well, this actually really angered a lot of ecologists because we didn't think that was true. So much so, I'm actually, I was going to say something here, but I'm going to skip over here and just say that there's been a lot of counter articles kind of disproving that line of reasoning. So Bill Baker and many others have posed some evidence that, here, I'll come back to this now, that forests are not as dense. They haven't filled in so much as to change the way fire burns. And so I actually have another co-author, Kiala Hagman, who had the task of actually pulling together all of the evidence that has been compiled to discredit these lines of reasoning in the literature. And so she did a fantastic job, had a large number of co-authors for this work. And basically, I'm just going to summarize them in some boring tables, but I've got the key punchlines here. So basically, one of their reasonings was that actually forests always had high density patches and that they're not very departed. I don't know if you've heard of Bill Baker's work with the General Land Office data set, but what Kiala and many other co-authors have done is actually gone in and done some really careful work to prove that forests actually weren't as dense back in the day as they are presently over large landscapes. Of course, there were some dense patches, but that's not not really what typically was the case. So she has this table that is pretty brilliant in the refutation of that. Another one of the arguments that comes from the same group is that fire scar records actually might have overestimated the frequency of fire, and that fires were not as frequent in the past as these records might suggest. And many citations actually have disproven that. And so again, this table goes into detail about why those arguments are not actually the case in most cases. And then finally, another argument that's been put forth by not only Baker and others, but some other scientists too, is that actually high severity fire was a component of historical fire regimes, and it isn't quite as departed as people are saying. There's some truth in that. Actually, in all forest types, whether we're talking about pine savannas, oak savannas, mixed conifer forests, there was always high severity fire in the past. But what has been shown over time is that those patches, the size, and the extent of severity have been increasing. So if this table were not enough, we also just had Sean Parks and John Abotsoglu published a paper showing further evidence of this increased area burned and high severity fire to rebut this argument. This is actually, it seems like a no-brainer in a way to me to present this, but it was really important for us to summarize all the good work that's been put into this and say, actually, these arguments are not quite true. You can find one place on a landscape where you could have had high density trees or a lot of high severity fire, but that narrative doesn't apply a lot of places. So that's the most complicated of these questions, but I had to dig into the tables for you. Okay, we then wanted to pivot our second question to kind of a whole other line of reasoning that happens out there. So you've heard me say that I'm kind of anxious to see pace and scale of treatment expand. And some people would argue that we can get that job done with just forest thinning. So it's kind of a win-win that way. We can thin our forest, get commercial value out of the trees, and that then we will be mitigating wildfire severity. Dr. Jim Agee was quoted with a nice quote down below that I'll let you read, saying something opposite. And what we've done within this set of papers is first kind of pose why we care. So there's quite a bit in the media around, can we just get this job done with thinning? And then the scientific consensus, very strong. Sometimes thinning alone works, especially if you have a fire that doesn't have a lot of wind associated with it and it might not burn very severely, then a thin only unit might be fine. We've seen that definitely in many cases. But in general, prescribed burning following thinning is really necessary to reduce those hazardous fuels. So if you wanted to read more, we have several review articles that we cite. I also have just a compelling example. So this is an area I run near my house in the Metro Valley, and we had a recent thin here, a logging sale where the contractor left way too much slash on the ground. And it's an example of how they accomplished reducing the canopy fuels. If we had a fire, actually did come through, it couldn't actually become a crown fire because there was too much space between the trees. However, that canopy got redistributed onto the surface and became an elevated surface fuel bed for fire. Unfortunately, that meant that when we had a summer wildfire in this area, it was too hot, and so all the trees died. So it's a good example of why we actually often need to follow up with prescribed burning. So coming back to this urgency of needing to increase the pace and scale of treatment, we're often talking about thinning and prescribed burning, but I think it's really important to acknowledge right up that that's only one tool in the toolbox and it doesn't apply everywhere. And so I actually have this quote that I wanted to read by Bill Tripp, mentioning indigenous burning or cultural burning. Fire itself is sacred. It renews life. It shades rivers and cools the water's temperature. It clears brush and makes for sufficient food for large animals. It changes the molecular structure of traditional food and fiber resources, making them nutrient dense and more pliable. Fire does so much more than Western science currently understands. And that's a really good reminder that one of the tools for restoration or adaptive management is really promoting and revitalizing cultural burning practices. Sometimes this might be for enhanced acorn production, as well as protecting the large oaks. And others, it might be for other culturally important resources or values. Now, thinning and prescribed burning, though, has had some stellar success stories. And I wanted to share one visual. This was repeat photography taken by John Marshall, incredible photographer. This was in the Sinlahican National Wildlife Refuge, just north of where I live in the Methow Valley. Top left shows unthinned, fire excluded forest. Top right, post thinning. Bottom left, the spring after a prescribed burn. And then bottom right, they actually had a wildfire come through this area in 2015 with just spectacular results. So it ended up being like another prescribed burn, a maintenance burn. Why couldn't we just do prescribed burning, since I've been saying is so effective? Oftentimes there's too many ladder fuels and too much accumulated fuel on the surface. And so here's an example here where a prescribed burn can come through, and you can see that the flame lengths are low and they're not probably going to torch into a lot of these trees. Whereas if we had a fire here, we could have a really late season wet burn that just kind of skunked around, and that might not be bad for reducing surface fuels. But the other problem with that managers are finding is that then that fire is too benign. It doesn't thin the forest. And so to get at drought tolerance or reduced vulnerability to insects and disease, there's too many trees. So you can do it with prescribed fire, but it might take multiple entries and a little bit bigger fire than you might feel comfortable using. Another area that is a reminder that we can't just use one tool in the toolbox is high elevation or cold forest. So in many mountain forests, fire is less of a frequent visitor, might come every 50 to 100 or 200 years. And when it comes, it often burns in patches. One of the things that I've loved about working more with Paul Hesberg is just his helping me to think about broader landscapes. And I used to think that the effects of fire suppression were not really noticeable in high elevation forests because fire was so infrequent. But he reminded me that actually we're missing all of those individual fire events over broad areas that punch holes in the landscape. And so a couple tools instead of thinning and prescribed burning that would work really well up in these areas to restore that patchwork are managed wildfires. So having a prescription for, say, late season wildfires that happen through either cultural burning practices or through lightning strikes that do this work out there. So I wanted to mention once again that cultural burning practices can be really critical to restore subalpine meadows and the plants and animals that they support. All right, so moving right along. I skipped a few of these, but I wanted to cover a few of the questions that are coming up quite a bit in the media. I don't know if you've seen this one, but there's an assumption that the primary objective of field treatments could be to contain wildfires. In fact, this has come up recently in some court cases. There was a U.S. 9th District Court of Appeals ruling against the Forest Service on a restoration project, in which the opinion was it is becoming more and more commonly accepted that reducing fuels does not consistently prevent large forest fires and seldom significantly reduces the outcome of these large fires. That's true. But what we would like to kind of remind people through this article is that the objective of these fuel reduction treatments is to not necessarily keep fire out, but allow fire to come back in and be a maintenance burn. And so there's been some recent media in Sacramento Bee. Crystal Colden was well profiled in this one. And some contrasting views came up. One was from Chad Hansen. This set of fuel treatments is not starting fires because they're mostly driven by weather and climate. You can't fight the wind with a chainsaw. Good point. But a program director at the Nature Conservancy countered, the goal of these treatments is to not stop wildfire in their tracks. It's to change the behavior where we can. This picture actually of my colleague Eric Knapp shows a really great demonstration of this. As you can see here, no more needles. So this indicates a crown fire on this side, and then a very sharp line to a treated area that had both a thin and prescribed burn, where the fire then dropped down and actually allowed some trees to survive. Here's another one. Many media sources have been showing this map of past management in the Boot Lake fire, which is a massive fire in Southern Oregon this summer. And here's a quote. Essentially, the fire burned through these areas really quickly. So the fire in its initial rapid growth burned right through these pretty expansive areas of commercial thinning and prescribed fire and did not seem to slow down. So again, we wouldn't expect them to necessarily slow down. It's really important to think about what fuels are burning after treatment. Oftentimes the fuels that are left following thinning and prescribed burning are grasses or shrubs or litter. And those really do support fast-moving fire. So it's actually expected. Here's just a great example from near where I live. This is the 2015 North Star fire that burned, unfortunately, quite a bit of the Colville Indian Reservation and then into the Tenasket Ranger District and then into Colville National Forest. In a field tour where I got to speak with the FMO of Tenasket Ranger District and the Confederated Tribes of the Colville, they were celebrating some success stories. So this is an example here showing the grass understory of an area that had a ponderosa pine forest that had been thinned and prescribed burned in advance of the North Star fire. Crews were actually able to get in there really safely because it was, just kind of pine savanna with grass, and do some pretty careful prescribed burns in advance of the North Star. And then it had to wrap around that burned area. So it actually was an effective barrier. And here's just one more example of a treatment unit where the wildfire actually had a pretty good head of steam and then gradually transitioned to a surface fire because of that treatment. All right. Another common concern, especially with climate change, is that fuel reduction treatments are an investment. They take a lot of work, have some questions about impacts to the environment too. And will they work under extreme fire weather? So once again, I'm finding these quotes kind of helpful to show what we were responding to. So I'm going to read this one. However, as the climate changes, most of our fires will occur during extreme fire weather. These fires, like the ones burning in the West this summer, will affect large landscapes regardless of thinning, and in some cases burn hundreds or thousands of acres in just a few days. So again, you're kind of seeing this confusion about what fuel treatments should or shouldn't do, but there's also a question of, will they hold up in extreme fire weather? Because that's what we're getting more with climate change. So We actually cite many cases to show that there have been extreme wildfires, such as the Rim Fire. Van Kane and others have studied the Rim Fire and field treatment effectiveness. But I'm going to just show one that's been close to home. This was the 2014 Carlton Complex Fire, and I actually happened to live right here, so had a almost front row seat. So what was pretty unique about the Carlton Complex Fire was it's one of our largest fires in Washington State history, and a good 2/3 of it burned in one day. And so I can't think of a more extreme set of fire behavior than this one. The morning of July 17, 2014, the fires were up near Winthrop, and this fire progression actually burned 40 miles, which is pretty staggering for a wildfire spread in one burn event. So as you can see over here, so this progression interval, this was the morning of July 17th, this is the afternoon. And you can see here in a burned area reflectance classification with red being high severity, that there's a big high severity swath there. And so when I kind of witnessed what had happened in the Carlton complex, I thought, this is the wildfire that's going to totally test field treatments and they won't be effective. We're going to actually be documenting a threshold of lack of effectiveness. And certainly looking over Upper Finley Canyon near Loop Loop ski area, the effects are pretty staggering. However, when we actually did an analysis of the drivers of burn severity, we found that it was actually much more promising than we thought. So I wanted to partition out the pixels of monitoring trends in burn severity, fire severity data into the early progression days and then later progression days to really evaluate those wind-driven fire progressions. And what I have here is a little bit obscured from Zoom, but I have pixels that were either thinned and pile burned, thinned and underburned, underburn only, and then past wildfires. So kind of a range of treatments. And what we found is that across these treatments, moderate and high severity effects were dominant, but the thinning and underburning didn't fare terribly. 42% of the area that was thin and underburned had low to even unburned severity. Later progressions, these didn't have the wind. It was much more benign fire weather. So a lot of treatments did a lot better. But another thing that we found through random forest modeling and looking at the local importance of variables was that the treatments that were in the leeward slope, so they were not exposed to wind, actually fared the best, which I think is kind of promising for local managers because the winds for the Carlton complex, just coming back to this, entirely predictable. They actually funneled down our valley and came from the west. And so we could actually think through scenarios in the future about hedging our bets with treatments located in the shadow of those future winds as well. So in answer, yeah, extreme weather is going to challenge field treatments, but they're still worth doing. We might need to be more strategic about where we place them. And so I'm going to conclude just with talking about the one more common question. I've actually not had, I put these into kind of more of a misconception for this presentation, but oftentimes there's a sense that the scale's too great. We're not going to catch up. In fact, in the recent Court of Appeals case, there was a quote saying, field treatments are unlikely to reduce fire severity and consequent impacts because often the treatment area is not affected by fire before fuels return to normal levels. So basically saying, you can invest all of this work, but you might not even be encountered by a wildfire. And that can be explained by just the drop in the bucket. We are really treating postage stamps on dry forest landscapes right now. If we treat at that intensity, they're not going to necessarily always interact with wildfires. If we treat more area, there's more chance of success that way. So that leads me to just some concluding thoughts. It was really exciting to work with this group of authors and the reviewers in this process to just really come together and recognize that we have a bunch of science-based adaptive strategies that are proven. The science is actually much more settled than maybe the media would want to or allow you to believe. So the main message is, yes, that's true. We're not currently treating enough area. Increasing the pace and scale will take huge investments, but I think it's important to recognize that not each and every treatment won't apply to everywhere. So for instance, thinning and prescribed burning, not really a suitable tactic for thin-barked species such as lodgepole pine or subalpine fir. But through a variety of these tools, we think we can get there, just have to do the work. So we also wanted to really recognize that climate change is already happening. We're no longer planning for the future of climate change. We're really living through it now. And so there's been some excellent articles on adaptive management. One is by Jonathan Koop, Wildfire-Driven Forest Conversion in Western North American Landscapes. And they cite Scott Stevens and others in acknowledging that we need to also have some prioritization strategies. In some cases, such as ponderosa pine or fire-adapted oak species, I think that a great strategy is to resist. Go ahead and restore the resilient structure, reduce the fuels, and hopefully those areas can last through even warmer, drier climates. Guide, where do we have moister forests that we might need to consider are going to be drier? Do we need to start changing our approach to management in those areas? Those are some tough questions. And then in some areas, we might need to accept that transformations have happened or are inevitable. So this might help us kind of target where our landscapes to put our work. All right. I loved that Malcolm North is next because I know that he's actually, through the abstract of his presentation, going to tackle some additional questions that we tackled in this review article. So stay tuned for next week. And I will just conclude by just sharing a little bit about myself. So I have a lab, we're calling it the Flame Lab, Fire Landscapes Adaptive Management and Ecology. You're welcome to check it out. PG Gall did a really nice job with it. And some of my research areas that I'm really focused on, I'm surprise, a lot on wildland field characterization to inform decision support. We're working on some pretty cool simulation modeling to look at what if scenarios. What if we actually manage 4 more wildfires out there in the roadless and wilderness areas? Can we get to more of a resilient landscape? And then decision support. I also wanted to acknowledge that I'm working with Allison Cullen and others on a really cool NSF convergence project where we're tackling this topic of changing climate and the reality of more simultaneous, really large wildfires. So this work is wrapping into that as well. With that, I will open up to questions. Okay. Awesome, great. So this is from David Butman. You presented a synopsis of fire management from a number of perspectives, including restoration. Have you had to consider the balance of both fire management and the potential for forest management for carbon to address climate change? Why, yes, we actually have a question on that. So we really struggled with how fire focused this article ended up being because adaptive management is integrated. You know, we're thinking about wildlife habitat and widespread tree mortality to drought. It's all wrapped in there together. And so one question that has been presented quite a bit is, can we still rely on our Western forests to sequester carbon and offset some of our emissions? In some places, yes, this is all going to be an ecologist answer. It depends. But in dry forests, fire-prone forests, that's becoming a little bit more difficult to envision. Oftentimes, when we see forests that are very dense and have a lot of fuels, that might have exceeded the carrying capacity for carbon on that site. And we might need to reckon with the reality that some of that carbon needs to be reduced in order for us to sustain those carbon stores for longer. So very complex issue, and one that's worth actually a lot more conversation. Yes, Liz. My research is tangential to that, but one of my close colleagues is Camille Stevens-Ruman from Colorado State University, and she's looked a lot on post-fire regeneration dynamics. The other person that will be really interesting to talk with is Malcolm North, because he actually has a great review article right now on adaptive tree planting. Oftentimes we're even reading in the scientific literature about regeneration failures, and some of our metrics might need to be reevaluated, such as the site didn't actually regenerate to stocking standards. Some of those stocking standards are probably too high for the new, drier, warmer, longer wildfire seasons that we're having. So great question. And I'm going to punt it to next week. Malcolm. No. Oh, great. Thanks. Douglas Martin. What can you tell us about the need and effectiveness of treatments for riparian stands? That is such an excellent question. So if Jim Agee were here, he could actually present some of his past research on looking at past fire frequency in Eastern Washington, East Cascades, between upland sites. So these would have been dominated by ponderosa pine, and then riparian forests that were more dominated by aspen and cottonwood. And some of his research, as well as Jessica Holofsky's in Oregon and many other studies, have often found that at least in the upland riparian areas, like not the big riparian floodplains, but those draws, like the tributaries, share the same fire history. So that's a pretty interesting consideration, because those riparian areas right now are chock full of fuels. And not only that, have some conifer invasion in them, and act as chimneys. So sometimes if you have a fire coming from downslope, the smoke and heat gets entrained into a riparian area, and the severity of that fire is quite intense. The great thing, though, about riparian forests in general is that those species resprout. And so this is kind of a simplistic answer, but through our observations of riparian areas that have been hit by fire in and around the Methow Valley, the riparian areas have actually been rejuvenated in many cases and come back with surprising vigor. So restoration is a tricky question. You know, do we do the same type of prescribed burning from in the riparian stands, or do we keep them shadier for fish? There are a lot of questions that I won't be able to answer, but would be worth really having a longer conversation. Okay. Does anyone from the audience want to ask a question? Jonathan.
So the term restoration.
Oh, thank you. Yeah.
This is like restoring to what?
So
you're basically picking, especially if this has always been this kind of like memorial anthropogenic landscape. Like, where are we restoring to? And in a lot of the thinning and burning projects, my personal opinion is they oftentimes put into place, none are the guys in restoration, but they're still profit by agents. So do you fear that with proposals of restoration, that when they get to the science sometimes gets left behind a little bit?
I'm really glad that you caught me because we're trying to get away from that term. Oh, yes, I'm so sorry. So that was, I just remembered that I'm supposed to repeat back a question. That was a long one, Jonathan. But so Jonathan had two parts to his question, really. One was about this term restoration. You know, what do we mean? What are our targets? And as a group of authors, we actually tried to steer clear of the term restoration. I use it still in my language because we talk about the cohesive strategy, which is restoration in it. But really, what are our targets now? That is a very interesting question. And we're talking more about future range of variability and future climate, future site types that will support drier climates, and we need to probably adapt to those, right? And so when I talk about adaptive management, there are some science-based strategies that we know work. Like I would say that agencies that are investing in thinning and prescribed burning in really drought-stressed ponderosa pine, probably a good idea in that case. That was the second part of the question is there a profit motive? I haven't seen that. I've actually seen that even those projects cost a lot of money, and that commercial logging is sometimes used to defray some of those costs, but it's certainly not a profit. And that the strategy of actually thinning the forest is probably a good one. But here's the deal. When we talk about adaptive management, it really does require monitoring and learning from what we've done, sometimes making mistakes, especially in a rapidly changing climate, and coming back to the drawing board and trying again. And so I think that I need to work on my terminology and really talk much more about adaptive management. And unfortunately, no, we don't have perfect targets. All right. Anyone else from the audience? Or should I go back to these? For sites rich in on-ground fuel, how does forward-looking management incorporate the effects of prescribed fires on soils, erosion control, and regeneration? Yeah, so that's a really big topic, and it kind of weaves into the riparian areas too. I'm just going to be able to touch on the fact that the adaptive management that is often planned is on public lands, always has an environmental review process, either an environmental assessment or NEPA planning, EIS. And so those questions about their potential impacts are considered. And so that's not exactly my area of expertise, but yes, prescribed fires, especially near riparian areas, can create some sedimentation for streams, for example. I think I'm going to stop there. And here's one more by Kira Hoffman. Thanks for your talk. BC is about to replant 2 million hectares of forests impacted by recent large wildfires. Do you have any thoughts on post-fire salvage and replanting wildfires in relation to reburn potential? I do. And so I've struggled with salvage. I was just talking about that with my partner at home, that like my gut level reaction to salvage logging is not a good one. It's like right up there with Smokey the Bear. But I've actually had some really informative conversations with colleagues about how if a forest is chock full of trees prior to a wildfire, those trees still exist in the landscape. And so it's actually through some great conversations and walking in the woods, post-fire woods with these colleagues, where I recognized that the reburn potential of those forests actually dropping down all around the same decade or two mean that there's continuous coarse wood on sites to support long duration burning. If we're hoping that those sites come back in ponderosa pine, western larch, Douglas fir, those seedlings can be cooked by that much fuel on the ground. And so oftentimes my colleagues are now talking about if a site needs to be thinned prior to a wildfire, probably needs to be thinned following wildfire. Of course, there's a lot of environmental review that needs to be done on soils and erosion, but that's where I've kind of heard Malcolm North will have some things to say about that one too. So you can ask him as well. All right. Thank you very much. This was fun.
Thank you, everybody.